Video in this unit is going to cover a topic that I'm really excited to teach you about called slope or rate of change. The reason why I'm really excited to teach you slope is twofold. Number one, it's something that I really enjoy doing myself. It allows us to do a lot of real-world problems, and it's used in a lot of projects and things like that. The other reason why I like teaching it is this is a skill that you already do every single day of your life. You just don't realize that you're doing it. And by covering this topic, not only are we going to be able to help you learn how to do slope in math class and in other classes, but we can also help you learn to use rate of change more effectively in your everyday life. So, slope means rate of change. It means from one value to another value, how much does it change and in what way? Now, whenever we're working with slope, I want you to imagine that there's a little car driving on your paper the same direction that you read, left to right. So if our car is traveling in a left to right direction and it's going uphill, we call that a positive slope. So the slope is positive if it's going up from left to right. Now, if the slope is going down left to right, we call that having a negative slope. Now, if the car is traveling flat, there's no vertical change at all, we say that has a zero slope or a slope of 0. And my personal favorite, if we have a slope that's so steep, it's straight up and down, you can't travel left or right at all, that slope is called undefined. So if you come and explain the differences between the 4 slopes and are able to name them, I will give you 5 SPs or a piece of candy. Now, when we're actually working with slope in math, most of the time you're going to hear it say rise over run. And you'll honestly hear that a couple hundred times over the next few weeks. Rise over run, rise over run. And what that means is the change in the y's over the change in the x's. Because rise is up and down. How much did you change going vertically? And run is left and right. So how much did you change moving from the left to the right? So we call that change in y over change in x, but most often you'll hear it said rise over run. Now, I personally like to say if you're working with a story problem, read your problem out loud. You'll frequently get things like miles and hours in your problem, and your options will be miles per hour or hours per mile. And when you read that out loud, you'll simply say, oh, miles per hour sounds like it makes more sense, so I'm going to make sure I divide my miles divided by my hours. And if you're careful to read your label out loud, you frequently will not make a mistake. Now, let's actually start working on some of these problems and see what they look like. So if I have 2 points, 2, 4, and 6, 10, and it wants to know what is the slope between these 2 points. The way you solve that problem is you pick a point 1 and you pick a point 2. And whatever point you pick for 1, you always go that direction from 1 to 2 or from 2 to 1. You never want to switch, and I'll show you what that means. So we're going to look at this second one here, change in y over change in x. And from this point, you want to find the change between your y values. So if I started with the number 4, I would go 4 minus 10 on the top of my equation. And on the bottom, I would do the change in my x value. So I'd go 2 minus 6. Well, 4 minus 10 is negative 6. Whoops. And 2 minus 6 is negative 4. And that simplifies to be a positive 3 over 2. Now, if you're working on a story problem, you also could write this as the decimal 1.5, but it just depends on what context the problem wants you to do. Now, if you're wondering if you could go from ordered pair 2 to ordered pair 1, the backwards of what I did, you still can. 10 minus 4 gives us 6, and 6 minus 2 gives us 4, which still gives us the same slope of 3/2 or 1.5. Now let's do the problem here on the right. Same thing, I'm going to pick an ordered pair 1 and an ordered pair 2. I'm going to go ordered pair 1, ordered pair 2. Now it's a little bit trickier to think about these points. because we got a bunch of negatives in here. So what I like to do, instead of writing out this whole step, is I just think about if I'm looking at the graph, am I going up or down? So from -3 to -5, I am going up 8. So that's a positive 8. And from -2 to -4, I am going down 2. So my slope ends up being, now there's a lot of ways you can write this. 4 over -1. You could write this as -4 over +1, or you could write this as just -4. These are all the same slope. Now, if I'm looking at this point right here, it says a line contains the points -3, or 0, 3, and 2, 5. What is the slope of this line? Now, once again, we're going to do the change in y over the change in x. So I'm going to look at, I'm going to take ordered pair 1 and then ordered pair 2. So I go from 3 to 5, and I say that I'm going up 2. And then from 0 to 2, I'm going up 2 as well. So my slope can be 2 over 2. It could be 1 over 1, or it could be just +1. All of these would be correct. Let's get a little bit trickier here. A line has a slope of 7 and includes the points -10, s and -8, 9, and wants to know what is the value of s. So we have to think a little bit backwards here. Now, the problem we have is that we don't have our y value, but I am going to stick, this is 0.1 and this is 0.2. So I'm going to look at thinking about my fraction here. I need something divided by something to equal 7, or 7 over 1, or 14 over 2. So we have a lot of options here. So let's look at our x values first. So if I'm going from -10 to -8, that means I'm going up 2, which means the denominator of our fraction is going to be 2, which means that our top has to be equal to 14. So that means from s to 9, I have to go up 14. So that means s has to be -5. Because -5 to -9, or +9, would be going up +14. So that's pretty tricky, but definitely not impossible. Now let's look at what slope means when we're working with it on a graph. So once again, we want to remember slope is rise over run. Okay, so what we have to do for this is we have to find 2 ordered pairs on our table, and then we have to find the rise and divide it by the run on that. So I notice that I have one ordered pair right here, and here is another ordered pair right there. We have to find ordered pairs that hit the corners. And so what I'm going to do is I'm going to take my little red here, and I'm going to count up how much it went up in my y value. So I noticed that my rise was $30. And then I have to go over with my run, which is over 20 visits, which simplifies down to 3 over 2, or $1.50 per visit. Now, if you remember from the beginning of this video, I said that be careful with your labels, because you can always think about like which would make sense. Would it make more sense to say dollars per visit, or would you say visits per dollar? And I'm hoping that you know dollars per visit makes a lot more sense than visits per dollar if we were actually trying to figure out what that was. So that means that when we're counting up our change in our y value, we're doing dollars divided by our visits. So let's look at the problem here on the right. Last problem of the video. Now we have to find 2 ordered pairs that hit on corners. So I notice there's one here, one here, one here, one here. So we have a lot of options. Now I'm going to pick these last 2 just to be a little different. And I want to know how much did we go up in our rise. So that means we went up 10 minutes in this problem. And we're going to divide that by how much did we go over in shirts? So that's 20 shirts. So that ends up getting 1/2, so that's minutes per shirt, which would be a half or half of a minute that way, which would end up being 30 seconds, actually, if we were trying to figure out this in seconds, but it wanted minutes for this one. So that is a really quick beginning look at what slope is. We're going to be covering slope for a few weeks in different contexts. So make sure if you have questions, as always, ask me. We can work through them together.